That's about how much will dissolve. Oh, see, it did make more solid.
It's so pretty.
Yeah. Okay. So to measure solutions, this is about quantifying how much. Actually, first we're going to do qualitative words, then we'll end up quantifying. Qualitative. Okay. Now, the qualitative word for how much is dissolved is concentration. What is the concentration of the solution? And a concentration is how much you've got dissolved in a given amount of solvent. Again, you can't just talk about what you got dissolved. You also have to talk about what you've got dissolved in and how much of that. Because can I dissolve a ton of sugar? Well, it depends on how much water I put it in. So concentration as a concept is about how much is dissolved. What is the concentration? It's like length. It's something you can measure. Now we are going to go to the adjective form of the word. Concentrated. A concentrated solution has a large amount of solute for the amount of solvent it has. A dilute solution only has a small amount of solute. Now, where people don't have problems with these ideas because these names make sense, right? Concentrated means it's got a lot of stuff. It's all concentrated in that spot. Dilute means it's all spread out. Got a little bit dissolved in a lot of space. But where people make the mistake is they get confused with saturated, unsaturated. They're completely separate questions. Say, what do you mean they're completely separate? One is about how much is dissolved. The other is about how much could be dissolved. Because you can have any combination. You can have a saturated solution that is dilute or concentrated. You can have an unsaturated solution that is dilute or concentrated. You can have any possibility.
Going back to the saturated, non-saturated, unsaturated, is that applied to fats and foods?
Oh, with that, what they're talking about is number of hydrogens. It's a double, unsaturated has a double bond. If you break that double bond, you can put more hydrogens on. So the double bonded one is unsaturated. Polyunsaturated means it's got lots of double bonds. That makes sense? And when you open up that double bond, it's got to open up so that they're across from each other, and you have a trans fat. That's where the word trans fat comes from, because you've opened up a double bond. But what I'm saying here about saturated, unsaturated, what I mean by separate, it makes sense that you could have a concentrated, saturated solution. That you've got a lot dissolved because it can dissolve a lot, but you can't dissolve any more. A concentrated, saturated solution. There's a lot dissolved. I can't dissolve anymore. Okay? How do I know I can't dissolve anymore? There's solid sitting at the bottom. Okay? It's concentrated and saturated. But I can also have a dilute saturated solution for something that doesn't dissolve very much. Only a little bit will ever dissolve, so I only got a little bit dissolved, but that's all I'm ever going to get. It is dilute, but it is saturated. It doesn't dissolve very well. I can have a concentrated, unsaturated solution. I've got a lot dissolved, but there's still room for more. See how they're different from each other? They're not this. It's what you're comparing them to. Concentrated and dilute are compared to relative. Saturated, unsaturated, there's a number you're comparing it to. Right? Did you forget that number or not? Okay, so the units. You saw that we had grams per 100 milliliters on the graph. That's one. Grams per milliliter, they give it to sometimes. Grams per liter. Although we tend not to work with liters of solution. Okay. You can use all those, but you need 2 units. And these are the kinds of units that you're actually going to see on the bottles of stuff you pick up and read, the ingredients list. Okay. They'll have those kinds of units. But we're worried about chemistry. And chemistry doesn't happen in grams. Chemistry happens in moles, right? So I need a unit for concentration that has moles in it. It's not completely new. I've talked about it a few times already. Molarity. Molar. Right? I've used those words before, right? HCl. When I gave you HCl in the labs, I said, this is 3 molar. It is 3 times as concentrated as the stuff in your stomach. I said those words to you, right? Okay, molar. Molarity is the number of moles in a liter of solution. So molarity means moles per liter. Because that means if I grab a liter of this stuff, I know how many moles I have and I can do chemistry with it. Or if I grab half a liter of it, I know how much stuff's in it. Right? Half of what would be in 1 liter. Symbol for molarity is capital M. And it's calculated by doing moles over liters, and its value is moles over liters. So that's the equation too. It's how the units work out. The units can substitute, and it's how the equation works out. So what is the molarity of a solution with 2 moles of NaCl in 4 liters of solution? So they want the molarity. Well, that equals moles over liters. Do we know moles? Yep, 2.0. Do we know liters? 4.0. Do we need a calculator? No. So that's a 0.50, 2 sig figs, molar. Or you could write it as 0.5 moles per liter. Those are both it's saying the same thing. So see how I said it's the equation and the units. Extra super hard? Okay. Okay, let's get harder. So much harder. What is a molarity solution with 3 moles dissolved in 250 milliliters of solution? Yes, you can. Let me bother you. Oh, you're really going to do that? No, you don't have to. Okay. Molarity is moles over liters. The number of moles, 3.0. They didn't give me liters. Hey, you can put milliliters down there, but it'd be wrong. It needs to be liters. And remember, to change from milliliters to liters, I just moved the decimal point. 1, 2, 3 times to the left. 0.25 liters. So 3.0 divided by 1/4 is 3 times 4, which is 12. Molar. Okay, well, that's not that hard. Let me kick it up another notch.
Yep, there it is.
You know what I was going to do next.
But wait, there's more.
Okay, 15 grams of NaCl occupy 75 milliliters. What is the molarity of the solution? Molarity is moles over liters. The 75, I can move it over 3 times and get 0.075. I don't have moles, though. I have grams. Hey, can we turn grams into moles?
Yes, we can.
We've done it once or twice this year. NaCl is 58.44 grams, 35.45 and 23 minus 0.01. That's the fast way to do it. 15 divided by 58.44 equals 0.26 moles. I put that 0.26 moles up there. And it's got to be moles over liters.
And then like converting.
Yeah, you could, but what you would have done, the conversion would have been this right here. It is the same math. No, it's okay if you did it that way. It's the same math. I just did it in 2 separate problems. Okay, divide that by 0.075. And I get that this is a 3.4 molar solution. That real tough? Yeah. Math's pretty straightforward. Complicated equation. Molarity is moles over liters. Okay.